Let's start. Last time हमने किया था कि I told you कि when you look at an atom and you look at an electron, so no one really knows what an electron actually looks like. All you see is a negative charge, or you don't even see a negative charge. You feel a negative charge. कि there is कि nucleus बीच में, and there's a negative charge that's surrounding it. Okay, so no one knows what that electron looks like. So a lot of people have described electrons as many different things. They've thought of it as a bee that's or bees that are buzzing around it. The nucleus beach mein, and the electron is like buzzing. The negative charge is buzzing around it. They've described it as a wave. They've described it as a cloud of negative charge that's surrounding the positive nucleus. So there are many different ways to think of it. The only problem is that when you see an electron, when you image an atom, all you see are these things. So all you see is you see a negative charge that's either spread nucleus center mein, okay? The negative charge is surrounding it in a spherical region, or it might have two lobes, or it might have, or the negative charge would be spread around 4 areas. So we don't know what that negative charge actually is. No one has seen that.
सर
हाँ जी
सर अभी तक कितना कवर आप बता सकते हैं अभी इस आज के लेक्चर में?
नहीं कुछ भी अभी स्टार्ट किया. ठीक है.
ओके
अच्छा, so the way you describe electrons is you describe the electrons as orbitals. ठीक है. So we did that last time, and I told you that orbitals are basically, it's a region of space around the nucleus where there's a high probability of finding the negative charge. So if the negative charge is it's present in a spherical region around the nucleus, that's known as an s orbital. Then that negative charge might be in a p orbital, which means that the nucleus would be in the center and the negative charge would be either on one side or the other side. The negative charge would be spread on two sides of the nucleus. जिस तरह यहाँ पे है, ठीक है. I mean, this one is a p orbital. The negative charge is found on top and bottom. The right side, left side, you don't find any negative charge. Or there might be a d orbital. A d orbital has 4 lobes, so the negative charge is found. If I show you on the diagram, I mean this diagram over here, this one is a d orbital, the one that has 4 lobes. That's known as a d orbital. So you've got SPD, and f orbitals. F orbitals के lobes थोड़े से ज़्यादा होते हैं. If I can show you over here what an f orbital would look like at the bottom pair. If let me scroll it down. So this one over here is an f orbital. Like if you take a picture of an atom, the negative charge is spread around the nucleus, but it's in 6, 7, or sometimes 8 lobes. So that's what an f orbital looks like. So electrons from now on would be described described by their orbitals. So you will be asked AS के अंदर the shape of the d orbital is not there. You'll be asked to draw the shape of an s orbital. You'll be asked to draw the shape of a p orbital. तो हम वो कर लेते हैं कि very quickly. Let's just talk about इस p को मैं हटा देता हूँ. एक सेकेंड. अच्छा, इस p को क्योंकि वो नीचे बना हुआ है p, just a second. अच्छा, instead in its place I'm going to draw an s orbital. So s orbital nucleus hai, and the electron would be present in a spherical region around the nucleus. Okay, so that's what an s orbital. So the negative charge would be spread around the nucleus, and that is our s orbital. So when it's there, that means the electron is present in an s orbital. These are your px, py, and pz orbitals. Now the s orbital doesn't have any variation. Why? Because it's a spherical orbital, so it's got only one orientation. The p orbital has 3 orientations. You got a px, a py, and you have a pz. Px का मतलब है the electron is on the x-axis, y means the electron is on the y-axis, z means the electron is on the z-axis. The negative charge is distributed around the z-axis. I said d की इसी तरह d की ना 4 variations होती हैं, 5 variations, sorry, and that's all orientation. के d has 4 lobes, so वो electron कहाँ पे exist कर रहा है, so it could change the planes. The orientation is different. Every time the orientation is different. Sometimes it's lying on the x-axis, sometimes it's on the y-axis. It's in the xy plane, xz plane. So the only difference is the orientation is different. So you can find electrons in all sorts of places. Just like a diagram, it could be the electron could have many different shapes, and the negative charge can be distributed in many different ways. So let's talk. पहले तो idea हो गया कि sp or d or f orbitals, ठीक है? So then you have subshells. Now the question is, what's a subshell? A subshell is basically a group of degenerate orbitals. It's a group of degenerate orbitals. When they use the term degenerate, that means same type. It means same type, identical, same energy level. So identical. So an example of a degenerate orbital is your p orbital. I mean, if you look at px, py, and pz, they are identical in every way. The only difference is the electron yahan pe it's on the x-axis, over here it's on the y-axis, over here it's on the z-axis. Otherwise, the distribution of the electron around the nucleus is identical. The d is also a degenerate orbital because the only difference is that the distribution of electrons, it's kind of identical, but the orientation is different every time. So these are known as degenerate orbitals. So, and they are identical orbitals except कि वो orientation different है. So you've got all types of subshells. You've got an S subshell. Now, when it comes to an S subshell does not have, I mean, the S orbital does not have any orientation. It's just one S orbital. Just one of them. Why? Because it can't have any orientation. ये जो spherical region होगा, even if you rotate it around, it's going to have exactly the same orientation. I mean, you can't do that what you did with the p orbital or with the d orbital. So there's no other version of an S orbital. There's only one version of an S orbital. So the S subshell only has one S orbital. When it comes to a p subshell, तो आपका जो p subshell है ना, that has 3 degenerate orbitals. You've got a px, and you got a py, and you have a pz. और ये सारे बिल्कुल similar हैं, except orientation is different. Now ये जो p subshell है ना, that's just a terminology that you use. It's just कि if अगर कोई p subshell की बात करेगा ना, what he's basically talking about is he's talking about all 3 orbitals together. Yani if I draw the axis, and if I draw the x, y, and z axis, and here's my top to bottom, that's my z axis. So if I draw, and the center is the nucleus. So हमने पढ़ा कि if this is the x axis, the electron in the px would be on the, it would be on the x axis. If this is the y axis and there's an electron in the py, then the electron would be lying on the y axis. And vice versa if the negative charge would be distributed around the y axis, and the electron might be on the z axis, so the negative charge would be located in these 2 lobes. So that's your pz axis. So these are 3 separate orbitals. But if you talk about them together, you group them together, this entire thing is known as a p subshell. Okay, so it's kind of the same thing, except कि जब आप orbitals की बात कर रहे हो, so you talk about them individually. You talk about PZ, so you're talking about this blue one over here. You talk about PX, you talk about this green one over here. You talk about PY, you talk about this specific orbital. But when you use the term P subshell, then you're talking about all of them together, ठीक है? और फिर इसी तरह you have a D subshell and you have an F subshell as well. तो अच्छा D और F की जो detail है ना, that's not in your course. You just need to generally know them. No one is going to ask you to draw them. अच्छा, so you've got a D subshell. D subshell has वो ऊपर picture थी. It has 5 different. A2 के अंदर जाके ना ये detail में पढ़ोगे. So right now it's just important that you know that there are 5 different orbitals, and when you group them together, that's known as, so that's what is known as a D subshell. कि हमारे पास ये जो 5 different D orbitals थे ना, जो ये है, if you talk about them together collectively, that's known as a D subshell. So up here, the F, is very rare. ज़्यादातर atoms के पास they don't have an F subshell. तो उसका तो कुछ भी पता करने की जरूरत नहीं है, except for just know one thing, that the F subshell has 7 different F orbitals. ठीक है, उसका बस एक जनरली से हम देख लेते हैं कि if I just Google what I mean, F subshell is like this. The electron has many lobes. The negative charge is spread, वो nucleus के the negative charge is spread in many lobes. ठीक है, so तो वैसी एक शक्ल दिखा देते हैं F subshell की कि it's something ये बल्कि ज्यादा सही है, F orbitals 7 होते हैं, ठीक है. So the negative charge around the nucleus is spread in many lobes, ठीक है, but in most atoms you don't have an F subshell. अच्छा, तो इलेक्ट्रॉन का जो नेगेटिव चार्ज है, that's distributed, उसके जो न्यूक्लियस है उसके इर्द-गिर्द it's distributed in many different ways, and these are your mainly 4 subshells. अच्छा,
Wilfred, how do you feel?
माइक किसी का ऑन हो गया. अच्छा, अब ये कि now the thing is कि let's focus on this picture again. Where's the picture? ये वाली. अच्छा, so the negative charge of the electron could be distributed in many different ways. तो अब हमें क्या पता कि where is the electron? Like, is it in the S, or is it in the P, or is it in the D? But before moving on, one very important thing that has to be talked about first is कि you've got all these orbitals. Remember that each orbital can accommodate a maximum of 2 electrons. That's it. यानी उसके अंदर ना 2 electrons का negative charge होगा. So each orbital can have maximum, I mean, they can obviously have 0 electrons, but they can have maximum 2 electrons. That's it. So if I have an S subshell, there's a spherical region around the nucleus. So इस spherical region में the maximum number of electrons that can be accommodated in this spherical region is 2. Now we don't know how those 2 electrons exist, because किसी ने भी आज तक, no one has seen those electrons. So the negative charge is just, I mean, all you can do is you can feel the negative charge. ठीक है, that's it. So the negative charge of the 2 electrons would be distributed around the nucleus in a spherical region, and you can have a maximum of 2 electrons. The same applies to a p orbital as well. Like if the electron is distributed in a p orbital, it's going to have 2 lobes, and there would be 2 electrons and their negative charge. Remember, it would be distributed everywhere in those 2 areas. तो वो 2 electrons का negative charge that's going to be distributed. It doesn't mean that there's 1 electron over here and 1 electron over here. What that just means is that the negative charge, which is 1.6 times 10 power minus 19 coulombs, अगर 2 होंगे तो double हो जाएगा, तो 3.2 into 10 power minus 19 coulombs. That negative charge would be distributed in this space. So maximum 2 electrons in a single orbital. And then there's another thing, which is that electrons in an orbital will have opposite spins. So electrons in an orbital they have just a second. So electrons in an orbital will have opposite spins. Now, what does that mean? What is opposite spins? So if I take an s orbital, और उसके अंदर ना there are 2 electrons that are located in that s orbital, ठीक है?
Sir?
हाँ जी.
Sir, तो like अगर s orbital में 2 electrons, तो p में like p में let's suppose हमारे पास 6 electrons, तो इस तरह से हमारे पास ये ऐसे ही होगा, मतलब multiply by 2 करेंगे जितने orbitals होंगे.
p में 6, हाँ मतलब p subshell में 6 होंगे. कोई भी ऑर्बिटल होगा ना उसके अंदर 2 इलेक्ट्रॉन्स होंगे. लाइक ये जो ऑर्बिटल नहीं थे जितने भी हमने, जैसे डी ऑर्बिटल है, इसके अंदर मैक्सिमम 2 इलेक्ट्रॉन्स होंगे. p this one will have 2 electrons. सबशेल में ज्यादा होंगे क्योंकि सबशेल इज उन सारों को ग्रुप किया हुआ है ना, so that's a total of 6 electrons. क्लियर है?
Yes sir.
मतलब डी सबशेल इन सारों का मिक्सचर होगा ना, you add them, मतलब सारों को ग्रुप कर दो, so that's 2 इसमें, 2 इसमें, 2 इधर है, 2 इधर है, 2 इसमें भी है, so that's a total of 10 electrons. ठीक है? But remember each orbital can have a maximum of 2 electrons. अच्छा, ये opposite spins वाली बात कर लेते हैं कि not only will there be 2 electrons but the 2 electrons are going to have opposite spins. इसका मतलब क्या है? इसका मतलब ये कि एक इलेक्ट्रॉन और 2 इलेक्ट्रॉन्स दोनों का नेगेटिव चार्ज they're going to repel each other. ठीक है? So electrons they repel each other. So it's very hard to actually keep the 2 electrons together because electrons they repel each other. तो दोनों इलेक्ट्रॉन्स एक ही जगह में किस तरह, how can the negative charge would be located in the same region at the same time? So electrons repel each other. इसका मतलब there is an electrostatic repulsion. मतलब electrostatic force क्या होती है? That's कि negative repels negative. So how can the force of repulsion get cancelled out? मतलब why can, because we need to cancel them out, otherwise दोनों electrons एक दूसरे को they're pushing each other out. So how can I remove this force of repulsion? So what happens is when you hear the term chemistry में ना, whenever you hear the term opposite spins, असल में हुआ ये था कि when in the 18th century when they discovered an atom and they started figuring out what an atom is, तो planetary model जो था ना वो follow होता था कि इलेक्ट्रॉन जो है ना स्पिन कर रहा है, ठीक है, या रोटेट कर रहा है या ऑर्बिट कर रहा है. वो तो बाद में जाके when you figure out कि when you started taking pictures of an atom and you figure out कि इलेक्ट्रॉन तो इस तरह नजर आ रहा है, it's just negative charge that's spread around the nucleus. तो उनको पता लगा नहीं मॉडल चेंज करना है, ठीक है. So they keep using the old terminology, but remember it has a different meaning. Opposite spin, chemistry के अंदर whenever you hear the term spin, it's got nothing to do with spin. वो जो literal English का word है spin, it's got nothing to do with that. What it simply means is it means magnetic field, or it means magnetic dipole. ठीक है? So it's got nothing to do with the word spin. Magnetic dipole means कि नेचर के अंदर ना there are three types of forces. There's gravitational force. Because of gravitational force, you have mass. Anything that has mass will exert a gravitational force. Anything that doesn't have mass is not going to exert a gravitational force. So that's one force. Okay, so all these particles, remember these are elementary particles. All matter is made up of these. So so they have mass. So which is obvious. So they have a gravitational field, and which is why they have mass. The second force that is electrostatic force, which is positive and negative charges. And then every elementary particle also has a magnetic force, which is when you talk about a magnetic dipole, dipole means two poles. It simply means there's going to be a north pole and there's going to be a south pole. So there's a third type of force, which is a magnetic force. Okay, and you know what a magnetic force is. So nature के अंदर matter usually exhibits these three types of forces. Gravitational force, which results in mass, electrostatic force, positive and negative, जिसकी वजह से सारी chemistry is happening. All the chemical reactions around you are electrostatic. I mean, कोई किसी के electrons को pull कर रहा है, कोई किसी को electron दे रहा है. So chemistry is all about losing and gaining electrons or sharing electrons. तो वो attraction क्या होती है? It's the positive nucleus attracting somebody else's electron. So all the reactions that are happening around you, आपके cells में, it's all this electrostatic force that's happening. और फिर
सर
हाँ जी,
सर मुझे ये समझ नहीं आया कि मैग्नेटिक डायपोल्स कैसे इलेक्ट्रॉन्स बन जाते हैं.
नहीं इलेक्ट्रॉन्स नहीं, कोई भी एलिमेंट्री पार्टिकल है ना, कोई भी पार्टिकल दुनिया में, कोई भी, लेट्स से दिस इज वन एलिमेंट्री पार्टिकल, even if it's a proton, even if it's a neutron, even if it's anything, ठीक है, उस पार्टिकल के पास तीन चीजें मस्ट है. It's going to have mass, ठीक है, it's going to have क्या कहते हैं an electric charge, ठीक है. Sometimes the electric charge gets cancelled out, but that doesn't mean it doesn't have an electric charge. उसका net electric charge gets cancelled out, ठीक है. And it's going to have a magnetic field. So any elementary particle, whatever, मतलब आप atom को pieces में break करो, you pick an elementary particle, it's going to have these three things. उसके ऊपर charge होगा, उसके ऊपर कोई magnetic, it will have a magnetic field, so it will act as a tiny magnet. It will have either positive or negative charges, ठीक है. Remember neutron जो है ना, that's not an elementary particle, it's made up of tinier particles. तो इसलिए उसका जो overall charge है ना, वो cancel out हो जाता है, and it's going to have mass. इस बार ये बात समझ आइए.
यस सर.
अच्छा, तो मैं ये कह रहा हूँ कि हमने हमेशा what we studied was कि we studied कि electron is negatively charged, ठीक है, which is fine. The electron is negatively charged, that there's no, ठीक है, it's got a negative charge, and it's got a very specific negative charge, which is minus 1.6 times 10 power minus 19 coulombs. तो हमने हमेशा पढ़ा कि electron, let's say this is an electron, so we've always studied that it's got a negative charge, and we always studied कि it's got a mass. Relative mass क्या होती है? 1/1840, ठीक है, which is कि it's 1840 times lighter than a proton. या उसकी जो mass होती है ना, अगर correct जो mass है ना, that's 9.31 times 10 power minus 31 kg. ठीक है, so it's got a mass, ठीक है, there's no confusion. What you have never actually studied is कि it's got a magnetic field as well. So this electron acts as a tiny magnet as well. Not only does it have a mass, it has a negative charge, but it also acts as a tiny magnet. जिस तरह वो बार मैग्नेट नहीं होता, although मतलब किसी ने आज तक इलेक्ट्रॉन को देखा नहीं है, so it's harder to visualize. But when you see an electron, you also experience a magnetic field, which means there's going to be a north pole and there's going to be a south pole, just like a tiny magnet. कि एक मैग्नेट होता है, उसके ऊपर ना वो फील्ड लाइंस बाहर निकल रही होती है, नॉर्थ पोल होता है, and there's a south pole जिसमें फील्ड लाइंस are entering, ठीक है. So when you see an electron, so you experience negative charge. At the same time, you experience a magnetic field as well. Is this point clear?
Yes, sir.
ठीक है, सारों को क्लियर? बाकी Siddha, is this clear? Rizwan, is this clear?
यस सर.
ठीक है, तो ये याद रखना कि Just a second. Achha, so just remember this, ke all elementary particles, ठीक है? Remember, neutrons and protons are not elementary particles. They can be broken down into smaller particles, but electron is, I mean, electron ko, no one has actually been able to break an electron down into a smaller piece, uh, which is why electron की mass बहुत छोटी होती है, ठीक है? So the thing is that think of the electron is in three ways. हमने कभी भी ना, we've never actually talked about it having a magnetic field. Like in all these protons, neutrons, and electrons, they all have magnetic dipoles. They're known as magnetic dipoles, or they're known as spins. Okay, so whenever you hear the term spin, that's the magnetic field of the elementary particle. Achha, so और ये आप लोगों ने पढ़ चुके हो. You've actually studied this in physics. Like, why does a current in a motor produce a magnetic field? Why do electrons moving through a coil produce a magnetic field? Because the electrons have a magnetic field, which is why they produce a magnetic field. Whenever physics you've studied, always studied ke, you've never actually been able to link this together, but कि wire के अंदर physics के अंदर क्या पढ़ा था कि if there's a current that's flowing through a wire, तो वो क्या होता था right hand rule के direction मुझे नहीं पता, but there's going to be a magnetic field, right? So why is there a magnetic field? क्योंकि the electron has a magnetic field. ठीक है, is this point clear?
Yes, sir.
ठीक है, और वो motor rule और right hand rule और left hand rule वो सारे, they were all, so where was that magnetic field coming from? Because the electron had a magnetic field. अच्छा, anyways, वो बात लंबी होगी, we'll just wrap this up क्योंकि it's a small point. कि the point was कि the electrons are trying to repel each other. Why are they repelling? Because one of them is negative and the other one is also negative. So that means their electric charges, the electrostatic force, that is repelling them. So how can I cancel that force of repulsion? The only possible way that the force of repulsion gets cancelled out is कि उनकी जो magnetic field है ना, if one of them is the north pole, the other one should be the, I mean, the other electron would be behaving, उसकी जो magnetic field है would be behaving as the south pole. तो अगर magnetic fields opposite हो तो क्या होगा? There's going to be attraction, right? और फिजिक्स के अंदर पढ़ा भी था कि वो जब दो वायर्स आपस में, if you remember physics, why did the wires attract each other? कि खास तौर पे if the current is flowing in the same direction, तो क्या होता था कि the wires would kind of attract each other. So the point was that it was the magnetic field that was attracting each other. So coming back to this, the point is very simple. Okay, you've got two electrons. So I'll just sum up the point, ठीक है, ताकि बात लंबी ना हो जाए. So the point was simple, that you have two electrons and it's very hard to keep two electrons in the same orbital. Why? Because वो दोनों electrons negatively charged हैं and they're going to repel each other. So they're not going to stay in the same orbital. But what happens is that the magnetic dipoles are going to be opposite. यानी उनकी जो magnetic fields होंगी ना, they're going to be opposite. If one of them is behaving as the north pole, जैसे दो magnets होते हैं, ठीक है, one of them is the north pole, the other one would be acting as the south pole. मतलब उसकी जो magnetic field होगी, that would be behaving as the south pole. If that happens, then the electrons would start attracting each other. So the force of repulsion would get cancelled out by the magnetic force of attraction. And so now the electrons can stay together because now they've learned to actually attract each other. So is this point clear?
Yes, sir.
ठीक है, और इसमें याद रखना कि if the other electron is also behaving as the north pole, फिर क्या मसला होगा? फिर तो then they're never going to attract each other. Okay, their magnetic fields would also repel and their electric fields would also repel. Then it would be extremely hard or impossible to keep the two electrons together. So to cancel out the force of repulsion, you need the magnetic dipoles to be opposite. So you want them to be opposite, so they start to attract each other. So that's the simple point. So याद रखना कि orbital के अंदर the electrons will always have will always have opposite spins. And a lot of times this is described as, an orbital is shown with a box, and it's represented by these two arrows, one pointing upwards, the other one pointing downwards. ये हम आगे जाके notation करेंगे. So a lot of times uh, orbitals are written as boxes, and the two arrows show two electrons having opposite spins. कि मतलब एक अगर north pole है, the other one is south pole, and they attract each other. So you want the electrons to have opposite spin. So that's just a minor point. तो यहाँ पे आपके orbitals में ना, whenever you have electrons and whenever you have two electrons, whether it's the s orbital or whether it's a p orbital or whether it's any of the orbitals, and there are two electrons. So whenever you have two electrons, they're going to have opposite spins. So moving on, we've learned subshells. The last part is, what's a shell now? Okay, that's the last part. And then we'll move towards how do we write the electronic configuration. So the last part is, what's a shell? Okay, so you got orbitals, you got orbitals grouped together into a subshell. And then the final thing is, what's a shell? That's a principal quantum number, also known as a principal quantum number or shell number. So it's going to be all sort of.
So what is a shell?
नहीं वही मैं बता रहा हूँ.
Okay.
That's a principal quantum number. Now in O-levels you studied that. You studied that shell is basically this spherical thing around जिसके अंदर electrons होते हैं, ठीक है? You studied that there's a, like if you had a sodium atom, then the sodium atom would have 3 shells, and the shells would become bigger and bigger. Now, it's kind of the same thing, except it obviously doesn't look like this. Like sodium has 11 electrons, 2 electrons in the first shell, 8 in the second one. And you had 1 electron in the third shell, okay? So in O-levels, you studied all of this. So what shell gives you an idea is, so remember, a shell never actually looks like this. I'll tell you the similarity with O-levels, but this is what a shell is. Shell is not. It's not a physical thing. Shell number or principal quantum number represents the energy level of the electron. So this thing represents. So this thing represents the energy level of the electron. So there's no physical manifestation. It's no physical thing. It's just if you have an electron in the s subshell, and the notation is that you'll write s and you'll write 2 or 1 in front of it. For example, you have 2s, you have 3s. So this 3 in front of it represents, and the electrons are written as a superscript. For example, there's 1 electron in the s and 1 electron in this s. So this 2 and this 3 is the shell number. So when the shell numbers or the principal quantum numbers increase, that means the energy level is increasing. So when they go from 1, shell number 2, then shell number 3, and shell number 4, all that indicates is that the energy level of the electron is increasing, or the electron is becoming more energetic. So when I write 4s, that means the electron is even more. So when I write 4s1, that means the electron is in an s orbital or s subshell, and it's more energetic. So what difference does it make? to the electron if it's more energetic, or what difference does it make to the orbital? So if the electron has less energy, that means the electron would be very strongly attracted to the nucleus, and the electron would be, and its negative charge would be very close to the nucleus. Its negative charge would be spread around the nucleus, but very, very close to the nucleus. So that is an electron that has low energy. If the electron becomes energetic, that means the electron is able to, the negative charge is able to move further away from the nucleus. The nucleus is attracting the electron, but the electron is now more energetic. So that means the electron, Hanji.
Sir, if like electron has if let's suppose it has low energy level, what would happen? Like it would be strongly attracted to nucleus. What would happen? Like
हाँ वही ना कि इसमें क्या होगा कि the electron, क्योंकि वो electron nucleus, क्योंकि electron doesn't have a lot of energy, so it will be strongly attracted to the nucleus, so it would be closer to the nucleus. Clear है? और अगर उसका
yes, sir.
अगर उस electron का negative charge है ना, that's more energetic, so that means the electron could be much further away from the nucleus. So that is what the difference is going to be. Okay, there's here's another S, and the electron is even more energetic. So इसका मतलब है the electron is occupying a spherical region, but now the negative charge is much further away from the nucleus. So eventually electron energy gain करता रहेगा. एक point आएगा, the electron would just fly away. मतलब it will leave the nucleus. ठीक है? It will no longer be, it will be so energetic that it would just fly off, and it would leave the nucleus. ठीक है? So this is what happens when your shell number increases. So remember, okay, it's the same orbitals, except इनके नाम लिख लेते हैं. Let's say this is 2s, this is 3s. So there's one electron and one electron over here, and this one is 4s, and it's got one electron as well. So shell just represents the energy level, and if the energy level keeps increasing, the electron would be further and further away from the nucleus. तो ये जो आपका O levels का diagram था ना, वहां तक सही था कि if the shell number is 1, the electron would be very close to the nucleus. If the shell number is 2, the electron is further away from the nucleus. If shell number 3, then the electron is even further away from the nucleus. और जितना वो energy level बढ़ता जाएगा, the electron would just eventually at the end of the day leave the nucleus. ठीक है? तो ये clear है? Okay, what's the shell number?
Yes, sir. Sir.
हाँ जी.
सर लाइक इफ अगर इतने एनर्जेटिक हो गए कि वो न्यूक्लियस को छोड़ अच्छा वो ये क्या डिस्टेबलाइज नहीं होंगे?
नहीं, उसके डिस्टेबलाइज क्या मतलब कि बस वो इलेक्ट्रॉन चला गया? इन
नहीं
व्हाट
सर, लेकिन
उसका
अगर एक्साइट करके चला जाए.
नहीं, मैं वही कह रहा हूँ ना कि उसका मतलब क्या है, कि पहले तो मतलब सोचो ना कि डिस्टेबलाइज का मतलब क्या है, कि मतलब क्या डिस्टेबलाइज होगा? कि nucleus है that's attracting all these electrons, right? So if this electron is very energetic and it's very further away from the nucleus, तो चला जाए ठीक है. तो वो बल्कि वो स्टेबल और अनस्टेबल का ना जो वर्ड का मतलब है ना, वो हम बाद में देखेंगे. ठीक है? when we do chemical bonding. ठीक है? क्योंकि मतलब destabilize is a word, but what does that mean? कि उसका मतलब क्या है? I mean, we have to focus on that as well. ठीक है? अभी तो खैर इलेक्ट्रॉनिक कॉन्फ़िगरेशन बस चेक करते हैं. ठीक है? we'll talk about that in chemical bonding. अच्छा, anyway, so three things. Let's just sum this up and start writing electronic configuration. So there are three things. You've got orbitals. ठीक है? Orbitals वो physical space होते हैं जहां पे आपको इलेक्ट्रॉन मिलेगा, जहां पे उसका नेगेटिव चार्ज मिलेगा. Orbitals grouped together, that's a subshell. I mean, a subshell is basically a bunch of orbitals. You're just talking about them together. So that's a subshell. And then you had the energy level, which is your shell. So remember, end में जो चीज है ना, that is, I mean, all you have is basically an orbital. ठीक है? Subshell reality में कुछ नहीं है. It's just a group of orbitals. or degenerate orbitals, same type. और shell क्या shell is it gives you an idea of the energy level, ठीक है, और energy level का हमने idea लगा लिया कि the electron would be close to the nucleus, so it would be very far away from the nucleus. Now the question is, how do we figure out how to write the electronic configuration? Okay, who gives us the idea of like how do we know okay, where is the electron? Like sodium has 11 electrons. So how do I know कि कितने electrons P में and D में F में, like how do I know that? So pretty much all atoms have exactly the same electronic configuration. They follow the exact same order. And there is the Aufbau principle, which is a table. So you're going to use this table. तो बस ये table एक जल्दी से कर लेते हैं. This table gives you an idea of कि कौन सा electron कहाँ पे होगा. It would be later on, it would be a lot better if you remember this table directly. I mean, remember the order directly. That's 3D, 4D, and then you have 4F. अच्छा ये नीचे चलता रहेगा. It's this is going to be 5P. And so on. G भी आ जाता है लेकिन वो atoms के अंदर there's, I mean, it's never going to come, ठीक है. Now the order is every time you just draw these arrows. ठीक है, draw these diagonal arrows and that will give you an idea of, and you keep following those arrows. So this will give you an idea of which electron would be filled in which orbital.
Sir?
हाँ.
सर ये आपने इससे पहले लिखा था कि हाउ टू राइट इलेक्ट्रॉनिक कॉन्फ़िगरेशन, तो हमें इस ऑर्डर में लिखना होगा.
हाँ, हर दफा electronic configuration you just start following the arrows.
Yeah.
These are the subshells. ठीक है, ये सारे आपके subshells हैं. Order क्या होगा? 1s होगा followed by it's going to be 2s, then 2p. What is इन arrows को follow करते जाओ. 1s, 2s, 2p, 3s. अच्छा नहीं, एक 1s, 2s, 3s. अच्छा 2p हो गया, फिर there's 3s, 3p, 3p के बाद 4s. ठीक है, 3p के बाद there's 4s. After 4s there's 3d, then it's 4p, 5s, and so on. उससे आगे भी चला, then there's 4d, then there's 5d. ठीक है, और ये it just continues. So every atom will follow the same exact order. बस इसमें ये कि एक दफा fill कर लो ना, make sure you correct the order कि इनकी position switch कर लेना, like the 4s and the 3d. मतलब इनका order खुद ही ठीक कर लेना. Once you write the electronic configuration, just make sure कि the 4s and you got the 3d. ठीक है, the 4s को अच्छा इसी तरह यहाँ पे मतलब वो shell wise कर देना. Although it's just a convention, you're going to fill the electrons and then just correct the order. तो आपको ना you'll just follow this electronic configuration. तो next class में फिर हम करते हैं, we'll write down electronic configurations of atoms and we'll learn more detail about this. ठीक है, but every atom is going to follow this arrangement कि पहले electron इधर जाएगा, फिर 2s में, फिर 2p, then there is 3s, then 3p will be filled, then 4s, then 3d, 4p, 5s. I mean until you run out of electrons. So pretty much all atoms will follow this Aufbau principle. ठीक है, चलो कल फिर कंटिन्यू करते हैं. ये कोई क्वेश्चन नहीं है?
सर?
हाँ जी.
सर इसके अंदर कुछ डायगोनल्स हैं जो मतलब यहाँ पे ऑर्डर के साथ मैच नहीं कर रही.
इस ऑर्डर के साथ?
यस सर।
नहीं, वो मैंने किया था कि आप ऑर्डर बना लो 1s2p 3d, मतलब जो एक दफा इलेक्ट्रॉन्स फिल कर लो ना, ये ऑर्डर इस तरह आ रहा था, देयर वाज 3d एंड 4s वाज ओवर हियर, ठीक है। मतलब पहले तो इलेक्ट्रॉनिक कॉन्फ़िगरेशन इन डायगोनल्स के हिसाब से करना, ठीक है। और ये मेरे ख्याल से 4d और 5p, नहीं कौन सा 4d और 5p, हाँ इन दोनों का ऑर्डर भी ना, इसको वापस कर लेते हैं। अब ठीक है ऑर्डर, वो डायगोनल्स के हिसाब से ना, राइट।
यस सर, अभी अभी उनका डायग्नोसिस मैच हो रहा है।
हाँ तो अब उसमें बस इशू ये है कि जब एक दफा इलेक्ट्रॉनिक कॉन्फ़िगरेशन लिख लो ना, तो उसको थोड़ा सा ना वो रीअरेंज कर देना कि असल में ऑर्डर में होता है कि फर्स्ट शेल, फिर सेकंड शेल, फिर थर्ड शेल, फिर फोर्थ शेल। तो फोर्थ शेल वालों को इकट्ठा कर देना, फाइव शेल वालों को इकट्ठा कर लेना, लेकिन पहले राइट डाउन द इलेक्ट्रॉनिक कॉन्फ़िगरेशन, ठीक है। क्लियर है?
यस सर। सर,
हाँ जी।
आप जब कह रहे हैं कि रीअरेंज करना होगा, तो रीअरेंज मतलब पहले एक जो लेवल वाले होंगे लाइक 3s 3p 3d, इनको एक तरीके से मतलब अरेंज करना होगा, बाकी को फोर को अलग तरीके से। आप इस तरह से कह रहे हैं, ऑर्डर वाइज कह रहे
हाँ वो कल करते हैं ना, क्योंकि अभी अभी एक इलेक्ट्रॉनिक कॉन्फ़िगरेशन लिख दो पहले, इसको फॉलो करते हुए
हैं?
हाँ।
या
जब वो आ जाए तो इनकी बस पोजीशन स्विच कर दो कि थ्री डी वालों को, थ्री वालों को
ओके।
इकट्ठा कर दो, वो फोर वालों को इकट्ठा कर दो, फाइव वालों को इकट्ठा कर दो, ठीक है।
ओके सर, ओके सर, थैंक यू सर।
चले, ओके, अल्लाह हाफिज।